Hello, welcome back to Blender CC Live Noding. In the previous live nodings, I talked about this selection masking node many times, and this guy right here, select mesh elements by location. And in this video, I'm going to show one node that's kind of using these nodes. They kind of work together. It's called Proportional Edit Falloff. So from the name, you can kind of guess what this is doing. It's like if you are working in Blender in edit mode and you are selecting something and you kind of having this selection fall off. Maybe I'll do a quick demo. So you have like these objects and then you're selecting a couple of vertices. If you just move it, it's just like that. But if you turn on these proportional and then kind of move it, you get like a fall off. So this is like a very cool feature of Blender. Very easy to use and very intuitive. So this is we're trying to do that inside Sverchok, but it's a procedural. So yeah, let's try doing it. Proportional. So we probably need some kind of objects. I will use hexagrid just because we have it. I haven't talked about this single node, but this guy is kind of cool. It's pretty intuitive anyway. This gives you a lot of options, but this guy generates hexagonal pattern if you kind of fit it the right way. Center. So I always made a mistake. Not the center is the vertices that you want. So you get this hexagonal pattern. You can increase it. So make it 12 by 12. So we get this. And based on this guy, I'm gonna show you if I bake this guy and then smooth it. Smooth, where's smooth? This guy is actually separate, so be careful with that. We need to remove doubles in order to make all the vertices kind of joined, but we don't care about that for now. So let's make some kind of masking based on the simplest one, center and radius. So let's plug in the original vertices and faces, and the output can goes into this mask, and this is for the original vertices. Proportional edit falloff, and let's do something with this guy. The easiest is to use a vector move, because you see the output of this guy is a coefficient. It's kind of like it's a floating value for each vertices based on the radius of the mask. If I move this at the moment, if I move it like just like this without any coefficients, everything's just gonna move up. And if I use this vertices mask, so I'm kind of moving it based on the mask, so there is no proportional, no kind of like no smoothing whatsoever. It's just like a 0 and 1. But if I use the proportional fall off into the multiplier, we should get the ability to smooth the one that's not selected and the one that's selected, which is this guy. So yeah, they're kind of working together. Ideally, I think the radius of the mask and the proportional will grow together. So maybe I should do that. I'll have like a floating value for the radius on this guy, and then for the other guy I'll have maybe either using addition or multiplications. So I'll try. Actually, it looks better if I use multiplications. Okay, so that's like a very basic example how you want to use this proportional edit falloff. So you basically set the mask, and then based on that selection mask, this guy kind of giving a smoothing area. Oftentimes we take the least masking, something like this, for granted, but this actually can be kind of complicated if you look at the code. But we kind of get it for free, so you can easily like maybe animate it, move it in X, move it in Y, even in the Z axis. There is a one kind of, I think it's kind of limitation with this node. Like if it's kind of goes too far, it's kind of error, like if just like red arrow like this, Sverchok's just gonna stop processing. So you can't have like two, if you hit this kind of error and then so it stopped working. So unfortunately that's maybe there is a way to get around that. For now it's not possible. Let's so this radius scale angle. Oops, no, we don't want that. Don't worry about that. I think but anyway, we can control the radius of this guy, and we can also try other modes. So we have smooth and we have constant. And we have invert square. We can kind of go through one of them one by one. There's a linear, spherical. Spherical looks nice. If you bake it out, of course, it's just gonna create this surface. You can smooth it. Actually, this guy is hexagonal, but you can plug in any kind of mesh. So instead of hexagonal, for example, if we want to change this, let's say if we are using plane MK2, we just need to make sure we plug it correctly. Okay, sometimes I think I'm trying to show you an example. Okay, so because we have so many connections here, if we actually we want to plug this guy in, but we don't want to lose the connections, we can use shift and then kind of make a cut like that, and then doing it like this, we kind of can easily connect the value. So this one expecting vertices, so just plug to that guy, and what else is expecting vertices, that guy, and this guy, and this is expecting the polygon, so plug that in. See that easily we can kind of plug a new value. So this is what do they call it? The reroute is very useful for that case. So now we can control this. I really like the plain MK2 here. We can easily do that and normalize it if you like. Change the stepping. If I'm not wrong, you can also try to apply vector noise or something. Vector noise. Maybe plug this guy like that, and then use a vector math. Oh, that's actually applying it to all of them. Maybe I should have used the mask value from this guy for the vector noise. Vector noise doesn't have masking yet. Maybe we can kind of multiply it with this guy actually. Instead of plugging it back there. This guy, vector noise. So we plug in the original vertices and we should get some kind of noise. We can output a scalar, and we can mix a scalar with this proportional edit. Actually, the vertices can come from this guy. Probably I'll try to mix it over here. Multiply the noise. Oh, there you go. So that's it's a basic effect, but still pretty interesting. It's pretty fun. Vector math in here, we can give it a multiplier, multiply by smaller value, so it's smoother noise, and control the influence. Bring it up, so we get that quite easily. Some kind of fractal terrain kind of design. File, save as. Maybe we can even kind of flip the value with the list masking. Vertices mask, radius. How do we flip this? I wonder if we can just invert it. So invert. We don't have invert here. Maybe this guy. Maybe we have invert negate. Oh, negate doesn't actually work like that. Stethoscope. Boolean. Maybe object. I think it's we have like a logic function here that can invert the masking, if I'm not wrong. Not more. Because this vertices mask is like a Boolean value. I thought I could just invert it for this guy. It should actually work. Invert, reverse, not reverse. List math. So let's check this real quick. Text viewer, and check all this view, and look at it here. See, it's all false, 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 and then it's all actually false. Oh, it's actually 1,600 objects. If we negate that bit, and maybe convert it. Still doesn't like it. Should be like a Boolean value. Interesting. Probably I need to ask Sverchok developer for that, but should be pretty simple to flip the true and false. Well, anyway, we can have this kind of control, so it's already pretty cool. Cell noise. Oh, I really like cell noise like that. Let's turn off the points and the edges. So that's pretty cool. We can also smooth it over here. Where is it? Don't worry about that. You can always bake it and then smooth it, and you get this result. Yeah, and it's all still procedural, and yeah, so that's pretty much it. It's a quick look on these nodes, proportional edit falloff, and we are using the select mesh element by locations, and this is what we get. I'll tidy this up a little bit, and then I'll give you this node tree. I'll share it into Gist. So thanks again for tuning in. If you have any question, feedbacks, just let me know down below. I'll see you in the next